All right, today we're going to learn how to solve nonlinear inequalities. And this is not something that you have done before, so this is a new lesson, but a lot of the things you have to do in the middle are things that we just finished doing. And so I decided to put this in with Unit A because it doesn't really go as well with Unit 2, even though it's in the second unit in the book, but it goes better with Unit A than it does with Unit 2. Anyway, to solve nonlinear inequalities, first you must find something called test intervals. All right, and so these are the steps for finding those test intervals for polynomial and absolute value inequalities. First, we're going to solve the corresponding equation. So that is what we just finished doing. So that step should be super familiar. Okay, and then everything else is going to be new. So then we're going to label each solution on a number line. Then we're going to choose an x value in each region. So your solutions are going to divide up your number line into multiple regions. And so we'll pick a number in each region and test it in the inequality. And then if you get a true statement, then that's going to be part of your solution. So we describe each region that resulted in a true statement. As the solutions. Okay, so let's get started. Let's start off with A. So first, I'm going to rewrite it as an equation. And then solve this equation by factoring. Okay, so this equation has two solutions, 6 and -1. So that is the first step. The second step is to label each solution on the number line. So we're going to draw a number line. Doesn't have to be perfectly spaced. So what I'm going to do is just the smaller number, -1, I'm going to put about here. The larger number, 6, I'm going to put here. Now, because this one is greater than, it doesn't have an or equal to, I'm going to mark these with an open circle. All right, so you use open circles for greater than and less than, and then we're going to use closed for greater than or equal to or less than or equal to. So if it has or equal to, it includes those points, and we use a closed circle. If it doesn't have or equal to, it doesn't include those points, and you have an open circle. All right, so what I'm going to do now is pick a number in each region and then test it. So to the left of -1, I'm going to choose -2. In the middle, I'm going to choose 0. And to the right, greater than 6, I'm going to choose 7. All right, I'm going to go ahead and bring down you don't have to rewrite it, but I like to be able to see it as I'm talking about it. Okay. So I'm going to plug all those into that inequality and see if I get a true statement or a false statement. So when I put in -2, -2 squared is 4. And then -5 times -2 is 10. And then -6 is less than 0. Okay, so we end up with 14 minus 6, 8 is less than 0, which is not true. So that is not going to be a solution region. right, 0 is super easy to test. Anything that is an x, but it kind of gets covered up, and you're just left with -6 is less than 0, which is true. So I like to go up and then shade it as a solution. Okay, then we'll test 7. So I put 7 in, square it, I get 49. 5 times 7 is 35, minus 35, and then -6 is less than 0. Right? When you combine those, you get 8. 8 is not less than 0, so that's a false statement. So those numbers in between -1 and 6 are our only solution. I don't know if you guys did interval notation whenever you were in Algebra 2. I hope you did. But we're going to use interval notation here. So interval notation, you have the smaller number on the left and the larger number on the right. Okay, you'll either have parentheses or brackets. So you use parentheses whenever you have those open circles. So when the answer is not included. Or I'll show you one in a second where we have infinity. You use open circles. You use parentheses for infinity and negative infinity. And then we're going to use brackets for closed circles. Okay, so the smallest number in the solution set is -1, so it's going to go on the left. The largest number in the solution set is 6, so it's going to go on the right. Because they were both open circles, because they were not included in the solution, we used parentheses. All right, now if you're still a little confused about interval notation, hang in there. We're going to do it on every one of them. It'll get easier and easier. Okay, this one, before I write my equation, I'm going to go ahead and get everything on one side of the inequality. Now there are some rules about inequalities. When you're rearranging, if you ever have to multiply through or divide through by a negative, you do change the inequality sign, but just moving that 4 over, subtracting 4 doesn't change the inequality sign. All right, so we're going to solve the corresponding equation by factoring. This is the way it factors, so we would get -12 plus 1 gives you your -11. So your solutions are going to be -1/3 and 4. So those two are what we're going to label on our number line. So on the left, we'll put our -1/3. On the right, we'll put our 4. Okay, and then we're going to pick a number in each region. So less than -1/3, I'm going to choose -1. You always want to choose 0 at some point if it is not one of your solutions to the equation, because it's the easiest to plug in. So 0 is going to be in between -1/3 and 4. Now we're going to plug these into this. Okay, this one's a little more difficult just to straight up do in your head. Now you can use a little basic calculator to do this too. But when I put in -1, -1 squared is 1. 1 times 3 is 3. right? And then negative 11 times negative 1 is 11 minus 4 greater than or equal to 0. So that's going to be 14 minus 4. 10 is greater than or equal to 0. Oh, I didn't do my open or closed circle. So because this one has an or equal to, because it's greater than or equal to, they're closed circles. And because this is true, we are going to shade toward the right. So from that closed circle to all the way to the right. Now I plug in 0. Everything that has an x becomes 0. We're left with negative 4 is greater than or equal to 0, which is false. Okay. Then when I put in 5, 5 squared is 25. 25 times 3 is 75. And then 5 times 11, negative 11 is negative 55. Right, so that's going to give you 16 is greater than or equal to 0, which is definitely true. So I'll shade to the right of 4. Okay, and then let's describe our solution regions. So when we look at this one right here, the smallest number that's included in that region is actually negative infinity. And infinity will always have a parenthesis because you can't enclose infinity. It's just smaller, smaller, smaller for negative infinity. All right, and then we go all the way to negative 1/3. And because there's a closed circle at negative 1/3, we do a bracket. All right, and then we're going to do this kind of wide U that stands for the union. And then we'll pick back up at the other shaded region where we have 4 with a closed circle. And then pointing all the way to the right is pointing towards infinity. And we do a parenthesis on the infinity. All right. Okay, let's look at this one. Let's go ahead and get everything on one side. And then write it as an equation. All right. And then this is a polynomial equation with 4 terms, so we're going to factor it by grouping. Okay, so looking at that one, I know for sure one of my solutions is 4/3. You might be able to look at the second one and tell. That would be great. If not, it's okay. Go ahead and add 4 and take the positive and negative square roots. Okay, so now we're ready for our number line. I'm making this one a little longer since we have 3 solutions. We're going to have 4 regions we have to test. So our smallest number is -2. And then 4/3 is 1 1/3. So that's smaller than 2. That's our next one. And our largest is +2. All right, this is extremely tedious, especially without a calculator. So I'm going to kind of write sideways. Let me write down the problem. So it's 3x cubed minus 4x squared minus 12x plus 16 is greater than 0. That's what we're testing to see if we have true or false. I am going to test -3. I'm going to definitely test 0. I can already tell you that that is going to be true. This one is annoying because I'm going to have to do a decimal. If you're using a calculator, a decimal is not too terrible. And then I'm going to test 3. All right, so when I put in -3 and cube it, I get -27. And -27 times the other 3 that's in front is going to give you negative 81. All right, then I'll put in negative 3 and square it and get 9. And then 9 times negative 4 is going to be negative 36. All right, and then I'll put the negative 3 right here. And negative 12 times negative 3 is positive 36. And then plus 16. So basically, we have negative 81 plus 16. Oh, and then greater than 0. So that's going to be negative 65 is greater than 0, which obviously is not true. All right, when I plug in 0, I get 16 is greater than 0, which is true. Okay, now these, we didn't have the or equal to bar. It was just greater than. So these are all open circles. And I'll shade between. Okay, so I already did this one in the calculator because I don't like decimals, trying to do them in my head. But whenever you take 1.5, and if you were using a little calculator, you would have to do 1.5 times 1.5 times 1.5. You get 3.75. And then when you multiply that by the 3 that's on the outside, you get 10.125. Right? Then when you square 1.5, you get 2.25. And when you multiply that by 4, you get minus 9. All right? And then negative 12 times 1.25 is going to be minus 18 plus 16 is greater than 0. All right, all that junk adds up to be negative 0.825 or 75. 75. It doesn't really matter because it's negative. It's definitely going to be false. Whew, okay, you guys are just going to have to trust me. When you plug in 3, you get 25 is greater than 0, and that is true. So this is a solution region. Okay. So I'm going to describe all the shaded regions. So starting from the left, the smallest number in a solution region is -2, but is open circle. So it's a parenthesis all the way to 4/3 with a parenthesis. And then the union of 2 all the way to infinity. All right. So this one, I'm going to go ahead and change it to an equation. Divide by the 5. And then for absolute value, we're going to have 2 equations. One where what's inside there equals 3. And then one where what's inside there equals -3. And then just solve each of those by adding 3 and dividing by 2. So we get 2 answers, 3 and 0, to the equation. And then for the inequality, we'll put them on a number line. Okay, because I have the or equal to bar, I am going to do a closed circle. Okay, then I'm going to put in -1. I'm going to put in 1. And I'm going to put in 4. Unfortunately, 0 is one of the solutions to the equation, so it can't be one of our numbers that we test. But this isn't too hard to put in, so it's going to be 5. And then when I put in -1 for x, it's going to be inside of the absolute value, -2 minus 3, whoops, which is the absolute value of -5. The absolute value of -5 is 5, so you get that 25 is less than 15, which obviously is false. Okay, when I put in 1, I'm going to get the absolute value of 2 minus 3, or the absolute value of negative 1. And the absolute value of negative 1 is 1. So 5 is less than 15. All right, when I put in 4, I'm going to get 8 minus 3 inside there, so the absolute value of 5. So that's going to be false, because it's going to be 25 again. Okay, so you guys try to do this answer on your own in interval notation, and then check with me when you're done. Okay, so the smallest number is 0, the largest number in our solution region is 3, and they both have closed circles, so it's brackets. Okay, I know this is a super long lesson, I'm sorry, but we're almost done. This last one, we're going to use a graph to solve it. But to use these graphs, the first thing we need to do is, even though this is an absolute value, normally we don't have to do this, go ahead and get everything on one side and 0 on the other, because we want to compare this to 0. All right, so at this time, this should match this, and it does. So let's think about what it means on the graph when the graph where it is less than 0. So less than 0 on the coordinate plane is going to be below the x-axis. All right, so I'm going to highlight everywhere where the graph is graphed below the x-axis. So to describe our solution regions, we're looking at the x's there. So starting here at this x, well, let me do an open circle. Why do you guys think I want to do an open circle? Because it's just less than. So open circle starts being less than or below the x-axis there, and then below the x-axis all the way till you get to that point, and then it bumps up above. So we need to this is our solution region, all of these x's. When I plug them in, I get something less than 0, something below the x-axis. So that is going to be from 1, 2, 3, negative 3 to 1, 2, 3, 4, 5. So that's how you use a graph to do it. They like to put these on the challenge exam, which is great, because if you understand it, you can get the answer right really quickly and save time for something else. All right, before we figure this one out, let's move everything to one side and write it in descending order. Okay, and then you can see that this matches this. All right, this time we're wanting to know when that graph is greater than or equal to 0. So greater than is going to be above the x-axis. So I'm going to go through and I'm going to shade. It's a little too wide. Let me try that again. Zoom in a little bit. Okay. So above the x-axis is going to be this part. And it stops, starts going below, and then picks back up. Okay, and then this time, because I do have or equal to, I'm going to do a closed dot. So that's where we start getting above the x-axis, and then to here. And then it starts back here, and then it's going to be above the x-axis forever and ever. So we have a solution region for all these x's in between, and then all the x's to the right forever and ever and ever. So to describe that region, we would use a bracket. That's 1, 2, 3 again. Yeah, negative 3 all the way to 1. And then picks back up at 3 all the way to infinity. All right, so that's a lesson about solving nonlinear inequalities.